Hello, in this video we're going to be talking about the light dependent reaction. So let's not waste any of your time, let's get right to it. Now we have spent 7 videos setting all this information up for these final 3. 2 on the light dependent reaction and then 1 for the Calvin cycle. So now what we're going to be seeing is that let me back up. You're not going to be seeing any new information because I've kind of said everything, at least in the general discussion. But what we'll do now is to really look at how this is happening, why it's happening, and all the little steps in between. So when we're thinking light dependent reaction, again, photosystem 1, photosystem 2, in the thylakoid membrane, the idea of getting the electrons through the system and getting the components built and made that are headed to the Calvin cycle. But again, looking at the diagram, and I've got the diagram numbered to correspond with the notes. But step number 1, part number 1, which is on the far left above the little Z light energy ray. Okay, you got that photo event. In other words, the photon is being captured or absorbed by the plant molecule. Okay, then that energy gets funneled down to where the electron is. Okay. Then in part 2, and the 2 is kind of hard to see because it's in the blue, but it's that funneling of the energy, the electron getting energized. The 2, if you want to play a little Where's Waldo, is just to the left of the last part of that black line that zigzags through. That zigzagging black line is meant to showcase the energy being funneled from molecule to molecule, headed to the reaction center where the electron is. Then the electron, once it gets energized enough, okay, shoots out of photosystem, or the photosystem, and then gets accepted by some sort of carrier. Okay, and then we go through the process. We get to the chemoosmosis part, where an ATP molecule is made, for part 4. We've looked at one diagram showcasing this. On the next screen we'll see another one, but it's the idea of working through that process designed to create all the components that are needed for the Calvin cycle, including the ATP to provide the energy for it. Okay, so again, here's a diagram. This is the same diagram we looked at earlier, but it's the idea of the light. And I apologize, that should say dependent. I got a little trigger happy with displaying, but that should say light dependent reaction. I apologize for that. So do make that correction in your notes, and hopefully you hadn't had a chance to start writing yet, but that should say dependent reaction. Okay, so again, some other details that we haven't talked about. Actually, I think we have, but we'll emphasize them again. But photosystem 1, okay, its electron, once it leaves, is going to be accepted by NADP, and of course the electron is connected to a hydrogen. We don't want to forget that aspect of it, but that's where the H now is from, and that NADPH is going to be going to the Calvin cycle, and that H is going to be part of building the glucose molecule. So if each of those NADPs are going to provide 1 H, then as you know, because you know the glucose formula, structural formula, that we're going to need 12 of those to head over to the Calvin cycle. So photosystem will be making those, just cranking them out as long as the sun is shining, which we know it always is, thankfully. Now, number 2 there, the electrons that are lost in photosystem 1 as it travels to the Calvin cycle gets replaced from the electron from photosystem 2. Okay, so photosystem 2's electron eventually gets to photosystem 1. Now, photosystem 2, its electron, since it does travel to photosystem 1, it gets its electrons supplied from water. And we looked at that early on. We've looked at it a couple times. But you can see in the diagram beside me, next to the green chloroplast, the very first part inside the rectangle, is you can see H2O there in the bottom left-hand corner being separated. Okay, so it's being oxidized, and then the electron is supplied to photosystem 2. Well, that is our video over the LDR, light dependent reaction, part 1. Next time, when we come back together next time, we'll be talking about the LDR part 2. So we'll see you then.